Welcome to Lesson 3 of Module 1 on Data Warehouse Concepts and Architectures. I'm going to start with an important historical question that I want you to think about throughout this lesson. What historical reason for data warehouse development does not primarily involve technology? This question is highly relevant today because the success of data warehouse deployment depends on this organizational capability. This lesson provides informational background about data warehouses as a context for detailed skills that you will develop in other modules. You have 3 learning objectives in this lesson today. You should be able to discuss historical factors that drove the development of data warehouse deployment and technology. In your own words, you should be able to explain characteristics of data warehouses. To clarify your understanding of operational databases and data warehouses, you should be able to explain several differences between the 2 types of databases. Databases support decision-making in organizations. The traditional decision-making hierarchy depicts management levels and volumes of decisions at each level. Organizations believed that operational databases would support decision-making at all 3 levels. Operational databases were designed for efficient transaction processing and support for lower-level decisions such as resolving order delays. However, organizations encountered great difficulty with usage of operational databases for higher levels of decision-making. This difficulty spurred the development of data warehouse technology and deployment of data warehouses starting in the mid-1990s. The failure of operational databases to support higher-level decision-making is a combination of inadequacy of database technology and limitations in deployment of databases. Organizations and DBMS vendors discovered that a single database could not be configured to provide adequate performance for both transaction processing and business intelligence processing. Organizations discovered that the lack of integration among operational databases hindered higher-level decision-making. This lack of integration was not a design failure, as operational databases primarily support transaction processing, not business intelligence processing. Organizations discovered that retrofitting integration for operational databases was difficult. Product vendors discovered that DBMSs lack key features to support summary data and analytical calculations, vital for business intelligence processing. The SQL group by clause was inadequate to specify queries involving summary data. The select statement in SQL did not have any features for analytical calculations, such as moving averages. Storage and optimization methods were inadequate for queries involving summary data. Gradually, solutions for these problems emerged in organizations and product vendors. Performance limitations demanded that data warehouses be separate from operational databases. The lack of integration required an intense focus on adding value to data sources through transformations and integration. Lack of features spurred development of a host of new features for representation, manipulation, storage, and processing of summary data and analytical calculations. Data warehouses have become an essential part of an organization's infrastructure to support business intelligence. Data warehouse, a term coined by William Einman in 1990, refers to a logically centralized data repository where data from operational databases and external sources are integrated, cleaned, and standardized to support business intelligence. The transformational activities, cleaning, merging, and standardizing, are essential for achieving value for business intelligence. Data warehouses are optimized for reporting, often involving summarization of large amounts of data, as well as periodic processing to integrate and transform source data. Transaction processing uses primary data from large volumes of transactions to support daily operations and short-term decision-making of an organization. In contrast, business intelligence processing uses transformed secondary data to support medium and long-term decision-making. A data warehouse provides value for longer-term decision-making through transformations and integration to operational databases and external data sources. Due to the support of different types of processing, operational databases differ substantially from data warehouses. Operational databases largely contain current data at the individual level, while data warehouses have historical data at both the individual and summarized levels. individual level data provides flexibility for responding to a wide range of business intelligence needs, while summarized data provides fast response to repetitive queries. For example, an operational database to support order processing requires data about individual customers, orders, and inventory items, while a business intelligence application may use monthly sales over a period of several years. Operational databases therefore have a process orientation, for example, all data relevant to a particular business process, compared to a subject orientation for a data warehouse, for example, all customer data or order data. A transaction typically updates only a few records in an operational database, whereas a business intelligence application may query thousands to millions of records from a data warehouse. Normalization is less important for data warehouses because of the focus on reporting rather than transaction processing. Operational databases are highly volatile, processing large volumes of transactions, while data warehouses are non-volatile, with periodic refreshment to integrate new source data. Operational databases primarily use the relational data model, while data warehouses use star schema patterns of tables, as well as a multidimensional data model. Schema patterns typically differ between operational databases and data warehouses. In an operational database to support order processing, many-to-many relationships, or equivalently associative tables, are typically used to represent an order heading and details. In contrast, a data warehouse will typically just show one level of detail and no many-to-many relationships. In addition, specialized relationships, such as self-referencing and identification dependency, are less commonly used in data warehouse designs. You will learn details about schema patterns for data warehouses in Module 3. This lesson has introduced important concepts about data warehouses to provide a context for detailed skills that you will develop in later modules. You learned about historical reasons for usage of data warehouses and development of data warehouse technology, important characteristics of data warehouses, and differences between operational databases and data warehouses. You should remember this background knowledge as you become engrossed in the details in later modules. In answer to the opening question, lack of integration is primarily an organizational issue, not a technology issue. The level of integration is a data quality concern. Low levels of integration do not typically impact operational databases that support transaction processing and short-term decision-making. The lack of integration is a major concern for data warehouses supporting longer-term decision-making. Achieving higher levels of integration may involve coordination and compromise across organizational units, not technology. Coordination and compromise is not easy to achieve. Many data warehouse projects have failed due to the difficulty of coordination and compromise. Technology to implement higher levels of data integration is important after coordination and compromise is achieved.